do it together, and I probably will repeat that question when I see you. Hopefully I'll see you next week, because that if I can't see your I need to see a reaction to see if there is some understanding. So what is happening in this one? The short DNA is shown below. Yeah, so we have a DNA. Is to be sequenced. Using your knowledge how the Sanger method works, I can't see, in the gel diagram, drawing the bands that will appear when DNA polymerase is added to the reaction along with 4 different nucleotide mixtures indicated. Note that some of these mixtures are not what would normally be used in the sequencing reaction. D-deoxynucleotide, DD-NTP, are added in relatively small amounts. The asterisk represents a radioactive label. Okay, so this is the primary of this label. So what you need to do is like this. This is what added in the first one. So what you need to say is how many basically, yeah, how many bands would you see on a gel when you add this first one, yeah? Let me make it clear. So when you add this, so you have your mixtures, and you can see that the only one that is actually with a TTP or a D-deoxynucleotide is a T, okay? So if I have a gel, yeah, and I'm running it on a gel, what would I see if I have this mixture? Do you understand the question? So let's see. What do we add here? We have 1 T here. Yeah, so that's my first T that I will see on the gel because that is added. Yeah, I have all my other 4 normal and I have the D-deoxy TTP. So I add 1 T here. Then I have a G. Then I have a C. Oh my goodness. And then I have another T. So that T will be another T here. Then I have a G. Let's do it a small G, it's easier. Then I have a C. Then I have a G. And I have another T. Yeah, so I have 1 T here, 1 T here, 1 T here. So that's 30. And then I have a C and a C and another T. And I have a G and a T. So that's my, that will be 4, that will be 5. Yeah. And I have an A, and I have an A, and I have a T. So that T is my 60. And I have a C, and I have a T, and I have a G, so that's my 7. And you can have one that includes the whole length, okay? So that will be my 8. So overall, what you should see in your first lane are 1, 2, 3, 4, 5, 6, 7, 8 bands on that. Yeah? Does that make sense? Now, what I want you to tell me, how many bands would you see? Yeah, I want to get a number from you guys in the chat. Why is it 8 and not 7? Because one will include the whole length of the sequence. Yeah? Will be one band that includes all of them. So that will be the 8th. Does that make sense, Rad? There will be a band that includes all the way to that end. Yes. Okay, so tell me number 2, how many you get? How many bands would you expect to have if, yeah, correct, Antonio. Yeah, Antonio got it correct. Anyone else wants to try and tell me? Yeah, Jason got it correct. Yeah, anyone else? I have Jason and Antonio both got it correct. Yeah, Riyadh correct. Yeah, anyone else? I need everyone to write a number. Everyone on this chat, and I'll check who is on there. I will pause the recording. So for lane 2, yeah, for lane 2, what I will get is that I have all the combinations and I have the DD-ATP that goes in, DD-ATP that will stop in this A, that's 1, it will stop in this A, and then it will have the whole length of the thing. So that will be 1, 2, 3. Yeah, so overall I should have 3 lanes, 3 kind of fragment lanes here. This one is more complex. Okay, this one, what you need to pay attention, and this is where the tricky part is, that, and you need to pay attention if a question like that happen given to you, is that you have a DD-ATP and a DD-CTP. DD-ATP is the only one you have that doesn't have a DATP. So once it gets to DD-ATP, that's it. It cannot continue anywhere. Okay? Because that will stop it. DD-CTP, on the other hand, you have a normal C, so it can continue. And this is why, if we go here, we will have a T. Okay, I'll say it again. So, because I have a DD-CTP and I have a DCTP, so didioxide CTP and dioxide CTP, that means that although CTP will come here, it still can continue with the chain because I have a DCTP. But if a DD-ATP gets in, it cannot continue because I have no DATP in spare. Okay, so let's do it together because it's more complex. So it gets here a T. Yeah, so a T gets in, that's not a problem. Now a G gets in here. Yeah, but then a C gets here. So I'll have one band on that. So I get a band for the C. Yeah, somewhere here. I can continue because I have a normal C as well. So there will be a normal C that can get C. But look what happens with this ATP. Yeah, so this will be a T, that's not a problem. This will be a G, not a problem. There is another C here, which can continue, so that's a second C. Yeah, it can be a G up here, and it can be a T up here, and it can be, and then there is another C, so that would be a third. There will be another C here, that would be a fourth. The only problem is now, not yet actually, there is a T, there is a G, there is a T. However, there is an A. And once this A gets in here, that's it. It will stop because I do not have any more A to continue. And this is why it will have 1, 2, 3, 4, 5 bands. Is that clear? Why number 3 will have 5 bands. Does that make sense? Sabina, Rhea, does it make sense why I will get 5? 5 bands. Juby, Alessandra, do you understand why you have 5 bands on that? Yeah, because you have, every time you have a C, it will stop. But the only time it will stop and you cannot continue is when you have an A, because you don't have a dioxide ATP. You just have D-dioxide ATP. So that cannot continue. This is why you don't have the whole full length of this. Okay, hopefully it's clear. If not, go over it and see what's up. Okay, last one. Can you try on your last one? Tell me a number for the last one. This is a mixture you have for the last one. Can you give me a number? Give me a number for the last one. Okay, I got a number. I need more numbers. Pay attention that there is an ATP, CTP, TTP, but there is no GTP. So if once the GTP gets in, that's it, stops it, yeah? Yeah, anyone wants to come in on that? So only one answer, and I'm not sure if they're sure about that. Anyone else wants to give me a number? Okay, let's do it together then. Anyone else? Okay, so the only one I have here, and I think only one person got it now, it's a DDGTP. Okay, so the only way to label it is if this is on there. But this cannot continue. Yeah? So I have a T, yeah? I have a G. And what happens once this G gets in? Only one band. Because it cannot, just cannot continue after that. If that makes sense. You understand why there will be only one band here? You don't understand, Rad. Why you don't understand that? What's the question? I'll go back. So, how is it only one? The reason it's only one is because, you see, there is a DDGTP, but there is no DGTP. So that cannot continue. The only way I can detect it is on a gel is because this is labeled. So the labeling is only if it is with this DD, so it stops it. Okay, so only then I can see it on a gel. So if I have a T here, yeah, then I have a T here, that's how a problem gets in. The only way I can see it is when I have my G. So the G gets in and it's labeled and I can see it, but I don't have anything to be able to continue that because this G now is with D-dioxide, which means it has an H and not an OH. And because it has an H and not an OH, the phosphodiester bond cannot be created and the nucleotide chain cannot be added. So it will pause and you get only one band. Yeah? Does that make sense? Is that clearer now? Any questions on that? So basically, this is how you see the different, the answer for that question. Okay, this one, the next question on the booklet is explain how automated DNA sequence works. So basically watch that video and summarize what the lady is saying. And this is what we talked about earlier.